start this recording here. Oh, good. Okay. So, oh, that's what I was doing. So what I'm going to do today is we're just going to go through the practice final that I posted, right? And so I've posted the solutions, but sometimes it's helpful if I just talk you through the solutions instead, right? So that's what we'll be doing this week. So today we'll start in the long answers. I'm not going to spend any time on the short answers, just like before a test. So we'll just do the long answers together, but don't worry, it'll be enough to keep us busy for a while. Yeah, good. Oh. Okay. Let's see, what else was I gonna do? Oh yeah, start a new one. Oh, I'll add. Final exam review, part 1. Up to. Right. So before we get started, the Learning Center, they have tutors, and so what they're going to be doing is they're going to host a Math 114, so a business math review session. There's 3 days of review sessions, and they're free, and you can just go, and they have extra practice problems. And so for those, it's especially good if you know that you're weak on some questions more than others, right? Then you can ask for extra practice or extra help for those. And so there's a sign-up sheet. You don't have to sign up to go to them, but it's helpful because then if a lot of people intend on going, then they can bring in more people to help out. And so there's a sign-up sheet here, but I'll give the times. Okay. So Math 114 final exam review sessions. Oops. Final exam review sessions hosted by the Learning Center. So I won't be there, but other people will be. So hosted by the Learning Center will be held in E213 on Monday, April 15th from 2 to 4, equals. From 2 to 4, Tuesday, April 16th, from 12 to 2. And then the last one is on the Wednesday, April 17th, and it's a later one from 5 to 7. I guess that's, we could go before class. Or no, we don't have classes that week. So there's 3 sessions. You don't need to sign up, but it would be helpful to know numbers. If you intend on going. it's definitely not something that you have to do. It's just there to help you. So it's kind of free tutoring for these time slots. And so the sign up sheet is up here. Like I said, you don't have to sign up. You don't have to go at all. Just something for you to be aware of. Okay. So, all right, let's get to this practice test. So the practice final I've posted, and like I said, we'll just do the long answer. We'll start with the long answers. So the way the exam is laid out, it's basically going to touch on all the tests. It's going to be like test 1, 2, and 3 kind of smushed together. And so it is a 3-hour exam. It can be a little bit on the long side. I like to make 3-hour exams kind of 2-hour exams, but I would say that this is more of a 2.5-hour exam. So you really want to keep your pace up. So it's going to start with merchandising, right? Moving your way through the formula sheet. There's going to be a merchandising question, and then there's a Cvp analysis question, right, where we had to build those profit functions. And then there's a simple interest problem, and then a compound interest problem, and then some annuities, and then ending off with a mortgage question, right? So the format that you're seeing on the practice test is the format that you can expect on the actual final, right? So those types of questions in that order. What I'll do here is call this a type. This is going to be a merchandising question. So an RV dealer purchases stock for $138,423, less 39%. The dealership marks up 25% of the cost for overhead and 35% of the selling price for profit. During a sale, this particular model of car was advertised at $119,995. Determine the cost, the selling price, and the rate of the markdown during the sale. And so it's asking for a couple of things, and we'll just kind of work our way through it. So we're given some things here. We're given the list price. The list price is $138,423. And the trade discount is 0.39. The reason I know that it's the list price and not the net price is because it's 138,000 less 39%, right? So the discount is applied to the list price to get the net price. And so that's how I know that it must be the list price and not the net price. The dealership marks up 25% of the cost for overhead. Remember, overhead is denoted by a capital E for expenses, right? So overhead expenses. And it's going to be 0.25 times C, the cost. And same idea, 35% of the selling price for profit. So then P, capital P is your profit, is going to be 0.35 times the selling price, S. Okay. These are from a long time ago. Let's kind of jarring when you jump right into it, right? But I think once you've seen it, it's going to be okay. During a sale, this particular model of car was advertised for $119,995. So that means the reduced selling price was $119,995. We have to find the cost, so that's C, the selling price, which is S, and the rate of the markdown, the ROMD, or ROMD. Okay. So first you want to see, okay, well, what do I know? What do I need? And so first thing that I can do is I can find, what am I given first? The list price and the rate of the trade discount. Right? And so I can find the net price. Remember that trick that we use, that the net price is actually the cost to the retailer, right? If we're at the retailer level, then the net price is the cost to acquire this item, right? And so we can find N is the list price times 1 minus the discount, which is 138,423 times 1 minus 0.39. One minus 0.39 times 138,423 is 84,438.03. The net price is the price to acquire. Is it a car or an RV, or what is it? The RV. Doesn't matter. So it is the cost. Therefore, N is equal to C. So from that, we know that C is 84,438.03. So there's kind of my first part of my solutions. So we found C. We have to find S, the selling price. We're given a couple of things, right? We know the reduced selling price, and we have to find the rate of the markdown, right? So we're not quite there yet, but if we can find the selling price, then we'll be able to find the rate of the markdown. Okay. So let's see here. I'll start with my go-to formula. My selling price is my cost plus my overhead plus my profit. And so I'm trying to find S. I know that the cost is 84,438.03, but what I'm going to do is I'm just going to leave it as C for now, because I also know that E is 0.25 times C, and P was 0.35 times S. Now you absolutely could go ahead and plug the C's in because you know what they are, right? But what I'm going to do is I'm going to combine these like terms and then plug it in just once. So S is C, or what I'm I'll write 1.25 C plus 0.35 S. I'll collect my S's on one side, so then I have S minus 0.35 S is 1.25 C. 1 minus 0.35 is 0.65 S is 1.25 C. 0.65 S is 1.25, and now I'm going to plug in the C as the 84,438.03. 84,438.03. 0.65 S is 105,547.5375. So S is 105,547.5375 divided by 0.65. So S must be 162,380.8269. So S in money is 162,380.83. Whew. So now we know the cost, we know the selling price, and we want the rate of the markdown on your formula sheet. You have two options for the rate of the markdown, right? You can find the amount of the discount, which is D, and then divide it by S, or because we have the reduced selling price and the selling price, I'm just going to use that the reduced selling price is S times 1 minus the rate of the markdown. Which means my reduced selling price was 119,995. Is 162,380.83 times 1 minus the rate of the markdown. Trying to solve for the rate of the markdown, I'll divide both sides by 162,000, 119,995 divided by 162,380.83. 119,995 divided by 162,380.83 is 1 minus the rate of the markdown. So 0.738972698 is 1 minus the rate of the markdown. Kind of doing a switcheroo where you have to add the rate of the markdown to both sides and then subtract 1. So the rate of the markdown is, so add the rate of the markdown, then 1 minus 0.7, oops, 0.738972698 minus 0.261027302 is the rate of the markdown. Or if you prefer, the rate of the markdown, 26.1%. That's fine too. So the first long answer will be something like that. kind of multi-phase, right? So where you have to find a couple of things to get the answer that you want, right? But they all kind of link through each other. Any questions about that one? All right. So the next long answer question is going to be one of these Cvp analysis. So the profit functions. So you have to make the profit function and then use it to figure out things like the break-even output and the shutdown costs, right? That kind of thing. So let's just read through this question first, and then we'll work through it. So Walmart plans to sell 200 barbecues next week at an average cost of $278 each. Their weekly staffing expenses are $1,945. How much must they charge for each barbecue to break even? So break even. And then part B, if they wish to make a profit of $1,500, what price do they have to charge? Part C, if they sell 90 barbecues at $400 each, how much profit will they realize? And then if they sell 100 barbecues, what's the minimum price they could charge to break even? So just kind of reworking this profit function to figure out, okay, well, what's the break even? What's the shutdown point? What market conditions would force Walmart to stop selling barbecues in the short run? So that's the shutdown point. And then that's plenty for that question. Okay. So we'll just hop to it here. So we're told, or we're given, that they're going to sell 200 barbecues next week. So we're given that X is 200. And we're also told that the cost is $278 each. The fixed cost, the only fixed cost that we're given is the staffing expenses, which is $1,945. If we know the cost of each barbecue, we know the variable cost because there are no other costs that we've been given here. Remember for the test, right, there was is there a woodworking one? I think they had like advertising costs per month, and so a couple of different fixed costs and a couple of different variable costs. But in this case, right, we've just got a cost, a fixed cost, and then a variable cost of $278 per barbecue, right? So we also can figure out the variable cost is the cost times X, which is just going to be $278 times X. We'll just leave it as X, even though we were told that they're going to sell 200 barbecues, but just to leave it open for any number of barbecues, I'll just leave it as X for now. And okay. So we need the profit function, first of all. And whether you have it memorized still or you just develop it from the formulas on the formula sheet, either way works for me. So the profit of X is starting down in the bottom right-hand corner of your formula sheet and kind of looping through and filling in the formula and building it out further and further is the total revenue minus the total cost, where the total revenue is P times X. We're not told what they're charging per barbecue. Right? We're told the cost per barbecue, but not what they're charging per barbecue. Minus the total cost, which is your variable cost plus your fixed cost. Those brackets are really important right? Because if you take out the brackets, then you have to bring in that minus inside those brackets. Right? So px, we don't know what it is, minus the variable cost, which was the 278x. And now I'm removing the brackets, so minus the fixed cost, which was 1945. So however you want to develop the profit function, if you just want to have that one that we developed together memorized, that's fine, or build it out. We can simplify this, right, because we've got a px and a 278x, and so we can combine like terms and say, well, that's x times p minus 278, and then minus 1945. So now we can figure out how much they have to charge for each barbecue to break even. Remember, the break even is when the profit is 0. Right? And so break even is when the profit of x is 0. Let x equal 200, because that's what they told us, right? They're going to sell 200 barbecues. So that's what we're going to assume for now until they tell us otherwise. Oops. So the profit of x is 200 times p minus 278, oops, minus 1945. Letting that be 0 is 200 times p minus 278 minus 1945. Now we can solve for p, right? So add 1945 to both sides is 200 times p minus 278. 1945 divided by 200 is 9.725, which is p minus 278. Add 278 to both sides. I get p is 287, oops, 0.725. So the price that they have to charge is 287.73 to break even. Assuming they're selling 200 barbecues. Any questions about that one? So part B, if they wish to make a profit of 1,500, so not 0 anymore, what price do they have to charge? So same question, just changing the profit from 0 to 1,500 and solving for P again. And so we're saying, okay, well, 1,500 must be equal to 200 times P minus 278 minus 1945. It's stealing that profit function that we built already. We have to add 1945 to both sides, and so we get 1,500 plus 1945 is 3,445 is 200 times P minus 278. Divide both sides by 200, I get 17.225 is P minus 278 So P, adding 278 to both sides, I get 295.225. So P must be 295.23 to make a profit of $1,500. Any questions about that one? So now, if they sell 90 barbecues, right? So now X is changed to 90 at $400 each. So P is now 400. How much profit will they realize? And so this is saying X is 90 and P is 400. We can use the profit of X is X times P minus 278 minus 1945. That was that general one that we developed. Now we can swap out X for 90. So 90 times P, which is 400, minus 278 minus 1945. We're trying to solve for profit. So now we have to really think about bed mass, right? Do our brackets first and then multiply it by 90 and then subtract 1945. So we get 400 minus 278. 90 times 122 minus 1945. So times 90 is 10,980 minus 1945. $9,035. Even. So you can see how it's really helpful to just build your general profit function, even if it doesn't ask for it, because then you can just use it for the rest of the problems instead of having to kind of develop it every time. Good. Right. Part D. If they sell 100 barbecues, so now X is 100, what's the minimum price they could charge to break even? So now the profit is 0. So now we're saying, okay, well, in general, the profit of X was X times P minus 278 minus 1945. We're forcing the profit to be 0. And we're saying, okay, we're going to sell 100 barbecues. What's the price that we have to charge? P minus 278 minus 1945. This is the same as what part? A, Y, and B, I guess, sort of. It's just that we've changed the X. So adding 1945 to both sides. So 1,000 times P minus 278. 1945 divided by 100 is 19.45. P minus 278. So adding 278 to both sides, I get 297.45. And because it's already to 2 decimal places, I'll just throw a $ sign on it.